learners, I welcome you to this new module of C++. It is evolution of object-oriented technique that had been due to strong need to symbolize the real-world objects with programming techniques. This simply helps the programmers to have a better vision for simulating different kinds of systems like education system, hospital management system, tour and travel management system, production system, etc. For all these systems, there are some common points that needs consideration. First, all systems are well defined so they can be automated. Second, each system can be decomposed into some smaller manageable subsystems. For example, education system may consist of payroll system, administration system, admission system, fee system, examination system, fund system, etc. Third, each subsystem consists of different entities that is dependent or independent with certain unique characteristics and behavior. For example, in admission system, we can have different entities like student, courses, admission fee, etc. These can be defined in a single class or different classes. Their behavior is determined by operations that can be performed on them like registration of student in particular course, admission based on merit. Technically, we can say object-oriented programming is a data-centered programming approach in which data is more securely bounded to its behavior. This technique prevents free flow of data around the system, thereby preventing accidental modification of data from outside functions. OOPS technique decomposes the real-world problem into number of smaller entities known as objects and then defines their corresponding data and behavior known as functions. The data is structured to characterize the objects. This data is accessible to only functions associated to that object. Different objects, for example, object X, object Y, object Z, having their respective data and functions, communicate with each other through their functions. It follows a bottom-up program design approach, and thus new data and functions can be easily added whenever necessary. Organization of data can be viewed as shown. Basic terminology. Before proceeding further, we must understand some of the basic terminology of OOPS. Objects. It is a single unit comprising of data and its function. It is a basic runtime entity in an object-oriented system and is most closely related to real world. The functionality of object gives it a life in the sense that it knows how to do things in its own. Customer, account, loans, fixed deposits, etc. can be different kind of objects related to banking system as shown in the figure. While in college, we may have student, courses, admission kind of objects. They can be represented as shown. Different objects interact with each other through message passing. For example, student object may send a message to course object for various kinds of courses available along with their fee structure and duration. Or customer object may request account object for amount balance. Objects takes up different memory space that stores data and its functions. Since memory partitions are independent, so objects can be used in variety of different programs without modification. Classes. Classes are one of the most significant feature of OOPS. It can be defined as a group of objects that share common properties and relationships. Classes are user-defined data type and behaves as built-in type of a programming language. In fact, objects are variables of type class. For example, car, bicycle, bus can be different objects corresponding to class vehicle. In this way, we can create classes that can symbolize real-world objects. Instantiation. Object is an instance of a class and process of creating an object is called instantiation. Message passing. As we know, different objects communicate with each other by sending and receiving information in the form of message passing. In particular, message sending means object is requesting for a particular behavior of the object to be invoked. The object will then receive the desired results after the execution of the function. For example, object vehicle has requested for the behavior speed in kilometers. Thus, the message passing concept is equivalent to communication between different persons, thereby simulating the real world situations. Dynamic binding. During the execution of a program, when a function is called, the code of function has to be linked with the code for calling function. This is called as dynamic binding. In other words, we can say that it is a process in which the address of function is determined at the runtime instead of at the compilation time. Characteristics of OOPS. Do you know, my dear students, object-oriented programming has certain unique characteristics which makes OOPS concept so essential. The very first one is encapsulation. Encapsulation is the technique of clubbing of data and function in the single entity class. Thus, object can be seen as a complete entity with data and its behavior. Next is data hiding. Data hiding does not mean to hide data so that it cannot be used, although it has similar impact of hiding your valuables from thief. Information has to be secured from mishandling. Encapsulation helps in protecting data to be accessed by any other object, function outside the class. Thus, only data members of a particular class can access their data member. In this way, we are hiding data from outer world. Data abstraction. Data abstraction means how to abstract data without knowing the procedure used. Technically, we can say that data abstraction is a technique by which data structures can be used without concerning about exact details of implementation. For example, multiplication of real numbers without actually bothering about how binary numbers will be multiplied internally in computer. Since classes use data abstraction concepts, they are known as abstract data types. Next is inheritance. What is inheritance? Very simple. You also acquire some of the characteristics or behavior of your parents. It is nothing but inheritance. So, it is the property of OOPS by which objects of one class acquire properties of object of other class. For example, two-wheeler, three-wheeler, four-wheeler can be different objects which acquire the property of class vehicle. This property ensures the concepts of reusability and extensibility of modules by just adding new features in the existing class without modifying them. Polymorphism. It is another main property of OOPS. In Greek, polymorphism means many forms. It is just like you have a nickname as well as school name. The same person can be called by different names. This is polymorphism. Take another example. A lady can be mother, sister, wife, daughter, professional, all at the same time. But she behaves differently in accordance to the person calling her. An operation may behave differently in different instances depending upon type of data used. Thus, it allows objects with different internal structures to share same external interface. Classes. We have just talked about classes in general. Now let's discuss them technically. Class can be defined as a single entity that encapsulates data and its associate functions. Thus, it defines the data that is to be used to represent an object and functions that can be operated on this data. Before using a class, it has to be declared and defined also. Class declaration. A class can be declared before it is being defined. The syntax is as shown. It is necessary to declare them before usage in case of nested classes. Otherwise, it is optional. Class definition. Class definition describes the type and scope of its member. The general format of class definition is as shown. Class name is the name of the class that is defined by user, the class body enclosed in the braces and terminated by a semicolon. Class name is used to create the objects of this class type. Data members are those variables that describe the characteristics of the class and are declared inside the class. They can be private, public, or protected. By default, they are private. Member functions are set of operations that are applied on the objects of the class. In other words, member functions of a class are accessible only through their objects. Definition of member function tells how an object will perform a function, while member function declaration will tell what an object can do. Mode of access. Mode of access means how to access class members. Mode of access of any class member depends upon its visibility. These are known as access specifier. They can be private, public, or protected. Private mode. When the class members are declared as private, they can be accessed within the class. That is, private data can be accessed by member functions of the class. By default, the data member of class is private. Such a mode helps in implementing the concept of data hiding and providing protection against data misuse. Public mode. When the class members are declared as public, then they can be accessed from outside the class. Protected mode. Protected mode is used mainly in inheritance. When the class members are declared as protected, then they are accessed by member functions of that class and any class immediately derived from it. Now let's take this figure. Here we have both private and public data member and member function. This data is not accessible from outside class. This data is accessible from outside the class. Member function can use private members. This is a general form. This can be illustrated by the example. In this example, base is the user-defined name of the class. Variable A and B are private data member that can be accessed by member function of that class. Enter dat and display are member functions of class are public by declaration. They can use private data members A and B. Arrays within the classes. Arrays within a class can be treated in the same way as simple arrays. The only exception is that they are arrays of data members. For example, here marks is an int array with dimension 3, which represents marks in 3 different subjects. It is a declaration of public member function for inputting marks for 3 subjects. It is defined outside the class like the array variable marks is declared as private member of class student. It can be used in member function like any other array variable and any operation can be performed on it. Classification of classes. Classes can also be classified as simple classes. It is same as we have just discussed. Local classes. Such type of classes can be defined and used inside a function or a block. For example, this is a function definition. This is local class within a simple function func. This is class definition. Here within a function object is created. This is the use of created object. Some of the characteristics of local classes are: they can use global variables with the scope resolution operator. They can use static variables declared inside the function. All member function must be defined inside local class only. They cannot have static data members. Enclosing function cannot access private members of a local class. Another type of classes are nested classes. Classes defined within the classes are called nested classes. For example, here classes are declared beforehand. Here X is an object of class 1, Y is an object of class 2. Thus, all objects of class 3 will inherit the objects X and Y. Such kind of association is called nesting or containership. Abstract classes. Abstract classes are those classes for which objects are not created. These are mostly used as base class. This will be discussed in detail during inheritance discussion. Okay dear, I am just stopping here. Next time we will be discussing more about class members. Thank you.